Okay everybody, what we have goals here for today, we're just going to do a short video on how to create this lab that I submitted for everyone to do. So what we're going to do is we're going to look at it over here, and we have to look at the IP address, determine whether or not it is a class A, a class B, or a class C. Okay, so first things we have to get out of the way. If it's going to be a class A, the first octet is going to go between a 1 all the way to 126. Okay, and if it's going to be a class B, it's going to go from 128 all the way to 191, and a class C goes from 192 all the way up to 223. That's an important piece to understand, because what we do then is we have to look at the first octet to determine the default subnet mask, okay? And then that'll tell us how many bits we have. So with that simple knowledge we have right here, let's go ahead and take a look at the first one, problem number 1. Not the example, but the first one, okay? The problem number 1, okay, we have 210 as our first octet. So if we look at 210 as our first octet, we can see it falls in the range of a class C, so we're going to say that it is a class C address. Now by default, we then need to know how many bits, and we covered this already, but we're going to cover it again in this chapter as well. Okay, there are 8 subnetting bits, or 8 networking bits default in a class A. So we'll make that a /8. There are 16 in a class B, so we'll make that a /16. And there are 24 255, 255, 255.0. There's 3 255s, okay? 3 times 8 is 24. There's 24 networking bits here. Now we're going to look up here, we're going to say subnet mask bit count. By a default class C will be 24. So what I want to do is just subtract that out. And that tells me that I borrowed 6 total bits to create a network, or to create additional networks on this class C, okay? That would make my subnet mask, my default, is 255.255.0. I borrowed 6 bits, which means if I were to break that down into binary, that last octet would look like this. 1, 2, 3, 4, 5, 6, and then 2 zeros following it. This bit here is worth 128 points. This guy is worth 64, 32, 16, 8, 4, 2, and a 1. Okay? As you can see, I didn't borrow the last 3 bits, 2 and a 1. I didn't borrow that. 255 minus 3 is 252. So my subnet mask is 252. Next thing you want to look at is the total number of networks created. So in the rules of subnetting, 2 to the borrowed amount equals the total number of networks created, 2 to the borrowed. So 2 to the 6, and if you do what I told you guys to do, on the right hand side of your paper, always put down your powers of 2. Okay, you can keep on going if you wanted to, it's up to you. But we're going to go down 6, okay? We borrowed 6 bits. 1, 2, 3, 4, 5, 6. That means I created 64 total networks. Next is a number of addresses on each one of those networks created. We also said in our rules that 2 to the remaining amount, or 2 to the amount that I didn't borrow, okay, would be the total number of hosts on each one of my 64 networks here, okay? So, I didn't borrow 2, 1, 2, that's 4. That's 2 to the second. And then 2 to the fourth minus, okay, and I'm sorry, 2 to the second, which is 4, minus 2, because I can't use the first, can't use the last, gives me 2. So that's the first one that we have done there. I'm going to step into the second problem here. Hopefully you guys have already worked through this worksheet and you've gotten it done, but I wanted to show you how to do it anyway. Right? Looking over here, I have 220. 220 fits in my class C. I know that I have 24 total bits, okay, in a class C, but I know that in this scenario here, they have 29 bits, okay, 29 minus 4 equals 5. So that means they borrowed 5 bits. So if I go over here, one, 2, 3, 4, 5, that equals 248, okay? 128 plus 64 plus 32 plus 16 plus 8 equals 248. So now my new subnet mask is 255.255.248. I did not borrow 3, I'm sorry, next step is the total number of subnets. I borrowed 5 bits, 2 to the 5th. 1, 2, 3, 4, 5. That means I created 32 total networks. I did not borrow 1, 2, 3, which is 1, 2, 3. 2 to the 8, 2 to the third equals 8. 8 minus 2. So what it says here, on this network here, 220.53.230.25, with a subnet mask. All right, sorry about that. We had a little bit of a computer crash. So, once again, we have 220.53.230.25. It is a Class C by default. The machine has 24 total subnetting bits to start with. We can see that in this scenario there were 29 bits borrowed, or 29 total subnetworking bits, which means they borrowed 5 because we took 24 away from the total amount, gave us 5. 2 to the 5th is the total number of networks created, that's 32. The amount of bits that I didn't borrow were 3 in that scenario, so therefore I have 8 total hosts on each one of my 32 networks. And I can't use the first and can't use the last because the one is the network address, one is the broadcast address, so I actually have a total of 6 total networks. Now let me get my dry erase pen here, and we're going to go ahead and we're going to do the next one, okay? Okay, this guy here, 199, still fits into this guy, so this guy is a Class C as well, which means he has 24 total networking bits, okay? 24 total usable, standard, and then he borrowed 3, which is this guy right here. 2 to the third is 8, so he made 8 total networks. Makes my new subnet mask 255.255.255.224. Okay, so everybody can see that. I didn't borrow in that case there. If I only borrowed 3, that's a mess. Okay. Only borrowed 3. So I borrowed these 3 here. 128 plus 64 plus 32 equals 224. I didn't borrow 1, 2, 3, 4, 5 total bits. 2 to the 5th. 1, 2, 3, 4, 5 is 32. Can't use the first, can't use the last. 32 minus 2 is 30. All right? Let's try number the next one here. The next one we drop down, okay? This one's a Class B network. So it's going to look a little different for us, okay? So we'll identify it as a Class B, but it says it's a /24. We know that there's 16 total in default, which leaves us 8 bits in total that were borrowed for networking. So it makes my subnet mask 255.255, which is my default for that one right there. I borrowed bits. Let me clean this up just a little bit. Gonna need a little more room to work. Alright. So in this case here, I've got my default subnet mask, which was 255 and 255, and then 1, 2, 3, 4, 5, 6, 7, 8, and then move this over. Gotta get it nice and clean or I won't be able to write on it, right? Okay. And then 1, 2, 3, 4, 5, 6, 7, 8. And we'll put our numbers here. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2046. And we can keep on going on and on and on and on and on. I think it's 4,092. Okay. So in this case here, we borrowed 8 bits, which means they're saying that we borrowed this entire octet right here got borrowed. So 1, 2, 3, 4, 5, 6, 7, and 8. But we didn't borrow anything from the last octet. That's important to pay attention to, because although we sit there and we'll say in our rules that 2 to the borrowed amount equals the total number of networks, and 2 to the amount remaining, okay, is the total number of hosts created, we still have to think inside when we're doing our ranges and our numbers. We got to think within the octets. So in this case here, I borrowed 8 bits. 2 to the 8th equals 1, 2, 3, 4, 5, 6, 7, 8. That means I created 256 total sub-networks. I didn't borrow the last 8, so I still created 256 hosts on each one of my 256 networks, and I've got 254 of those that are usable. What is my subnet mask? Well, if I borrowed all 8 bits, it's going to look like a Class C, but the first octet tells me that it was a Class B to start with. So when the router gets involved and it does the ANDing operation, the first thing the router is going to do is look at that first octet and say, it's a Class B. Then it's going to look at the subnet mask and say, but they borrowed bits to make additional networks. Therefore, the router knows that it has 256 networks to choose from when it makes its best path decision on where to send your data. Let's look at the next one here, 131. 131 we know is a Class B network. Okay? It says it's a /20. We know that there's 16 total networking bits in the default, so let's subtract that 16 out of there. And we know that we now have borrowed 4 bits. If we borrow 4, That means this 128 plus 64 plus 32 plus 16 equals 240. So you put your first two down by default, which is 255.255. The next one is 240.0. It's all out there in binary for you. 255 by 255 is my default. 240.0. I borrowed 4 bits. 2 to the 4th equals 16. Now, don't get yourselves confused here, okay? It's not just that I didn't borrow 4 bits in this octet, I also didn't borrow 8 bits in this octet, okay? So that means I've got 12 total bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's going to be 4,092, I believe. I might have to double check my math there. I believe we put it for you on the bottom of these papers, so you're going to scroll up here real quick. There it is in the bottom. And 2 to the 12th is 496. Sorry about that. There we go. Okay. Let's fix this first. 2048. I don't know where I came up with 6 on that one there. 4,096 here, 48 there. Okay. So that means I have 2,048 and I have 2,046 usable on each one of my 16 networks. That's a large network to deal with, that's for sure. Let's do a class A here real quick. Okay, we're sitting here in a 10 dot network. It falls inside of this range here. We know by default it's going to be 8 bits, so we have another 4. My subnet mask by default on this guy here would be 255.255.255.0. Go and get that out of there. And we borrowed 4 bits. So let's mark that off. 1, 2, 3, 4, and then put your 4 zeros in. 2, 3, 4, because you have to fill the entire octet. That's important, okay? That means my subnet mask, my default. Oh, I'm sorry, I got that wrong. Scratch that. Even I make mistakes, folks. There we go. Dot 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I'm at 255.240.0.0. Let's go ahead and mark that in the worksheet. 255.255.